Lesson 2.3, Tables and Graphs of Proportional Relationships. The target is, I can recognize proportional relationships in tables and graphs. Example 1. Kathy recorded the number of hours she babysat compared to the amount of dollars earned in the table at the right. Is this relationship a proportional relationship? If so, give the constant proportionality. So the first thing that we're going to do is we're going to find the ratio of dollars earned to hours worked. And we're going to set that up, and we can see that dollars earned has a y next to it. And so I'm going to put a y as my numerator, and hours worked has an x, and so I'm going to put that as my denominator. That will make more sense here in just a second. When we look at the table, it's important that when we have 0 hours worked, we also make $0. That's an important stat that we're looking for. Then what we're going to do is we're going to write a ratio with the y value, the dollars, 10, over the x value, which would be 1. And I could simplify that to 10, or 10 over 1. And then I continue to check this, and I want to see when Kathy works 2 hours, she makes $20. So we're going to write that as 20 over 2, which equals 10. 20 divided by 2 is 10. Then I'm going to check 30 divided by 3. And I get 30 divided by 3 is 10. Then I'm going to check 40 over 4. Simplifies to 10. And I'm going to continue this process until I've checked all of the numbers. So I have 2 more to check. I have 50 over 5. 50 divided by 5 is 10. And I have 60 over 6. And that simplifies to 10 as well. 60 divided by 6 is also 10. So since the ratios are equal for all pairs of values in the table, the relationship is proportional. The constant of proportionality is $10 per hour of babysitting. So I could write that as, yes, it is proportional. And the constant of proportionality is $10. So the constant of proportionality is $10 per hour. Extra example 1. Is the relationship a proportional relationship? If so, give the constant of proportionality. So immediately we identify that we go through the point 0, 0, which is a good thing. And we use the same process as we did on the last one, where we're going to write the y value over the x value. So I look at my table and I see my y value is 14, and my x value is 1. And so 14 over 1 is how I write this as a ratio, and that would be equal to 14. Then I do the same thing with the next row in my table. So I go 28 over 2, and I get that from the x location, and I get the 28 from the y location, and 28 divided by 2, 28 divided by 2 is 14. Next, I have 42 divided by 3, and 42 divided by 3 is 14. My last one is 54 over 4, and 54 divided by 4 is 13.5. So we can see right away that it's not the same value each time. So we don't have the same ratio going on here. So this would be no, it is not a constant proportionality. You try. Determine whether or not each table models a proportional relationship. If so, find the constant proportionality. You try. Determine whether or not each table models a proportional relationship. If so, find the constant of proportionality. You try. Determine whether or not each table models a proportional relationship. Direct variation graphs. A graph shows direct variation if it is a straight line that goes through the origin. Good to know. In some cases, a table may not list the origin as one of the ordered pairs. If the ratio of y over x is the same for all pairs listed in the table, then the origin will be a point on that line, even if it is not listed. So as we can see here in our example, we do not see in our x and y points 0, 0 in our table. But as we notice here, all of our ratios are the exact same. They're all 3 over 2. And when we graph this with our x and our y, we graph the points, we can see that it goes through the point 0, 0, even though it's not listed. It goes through the origin, and it is a straight line. Determine if each graph models direct variation. Explain why or why not. A is direct variation, so it would be yes. And the reason why is it is a straight line and it goes through the origin. B is no, because it does not go through the origin. And then as we can see, C is no, it is not a straight line. So A is yes, it's a straight line, goes through the origin. B is no, it does not go through the origin. And C is no, it is not a straight line. You try. Determine if each graph models direct variation. Explain why or why not. You try. Determine if each graph models direct variation. Explain why or why not.